Today we're going to be learning about the seasons, and this is actually going to be the last topic that we have for this year. So we're going to go ahead and read through the text that goes with that, and then we'll be taking some notes in our notebook. Annual motions. Earth orbits the Sun in a slightly elliptical orbit, as shown in figure 27:15. The plane of Earth's orbit is called the ecliptic plane. As Earth rotates, the Sun, planets, and constellations appear to move across the sky in a path known as the ecliptic. As Earth moves in its orbit, different constellations are visible. The effects of Earth's tilt. Earth's axis is tilted relative to the ecliptic at approximately 23.5 degrees. As Earth orbits the Sun, the orientation of Earth's axis remains fixed in space so that, at a given time, the northern hemisphere of Earth is tilted toward the Sun, while at another point, 6 months later, the northern hemisphere is tipped away from the Sun. A cycle of the seasons is a result of this tilt and Earth's orbital motion around the Sun. Another effect is the changing angle of the Sun above the horizon from summer to winter. More hours of daylight cause the summer months to be warmer. Solstices. Earth's orbit around the Sun and the tilt of Earth's axis are illustrated in figure 27:16. Positions 1 and 3 correspond to the solstices. At a solstice, the Sun is overhead at its farthest distance either north or south of the equator. The lines of latitude that correspond to these positions on Earth have been identified as the Tropic of Cancer and the Tropic of Capricorn. The area between these latitudes is commonly known as the tropics. Position 1 corresponds to the summer solstice in the northern hemisphere, when the Sun is directly overhead at the Tropic of Cancer, 23.5 degrees north latitude. At this time, around June 21st each year, the number of daylight hours reaches its maximum, and the Sun is in the sky continuously within the region of the Arctic Circle. On this day, the number of daylight hours in the southern hemisphere is at its minimum, and the Sun does not appear in the region within the Antarctic Circle. As Earth moves past position 2, the Sun's altitude decreases in the northern hemisphere until Earth reaches position 3, known as the winter solstice for the northern hemisphere. Here the Sun is directly overhead at the Tropic of Capricorn, 23.5 degrees south latitude. This happens around December 21st. On this day, the number of daylight hours in the northern hemisphere is at its minimum, and the Sun does not appear in the region within the Arctic Circle. Then, as Earth continues around its orbit past position 4, the Sun's altitude increases again until it returns to position 1. Notice that the summer and winter solstices are reversed for those living in the southern hemisphere. June 21st is the winter solstice, and December 21st is the summer solstice. Equinoxes. Positions 2 and 4, where Earth is midway between solstices, represent the equinoxes, a term meaning equal nights. At an equinox, Earth's axis is perpendicular to the Sun's rays, and at noon the Sun is directly overhead at the equator. Those living in the northern hemisphere refer to position 2 as the autumnal equinox, and position 4 as the vernal equinox. Those in the southern hemisphere do the reverse. Positions 2 and 4 are the vernal and autumnal equinoxes, respectively. Changes in altitude. The Sun's maximum height, called its zenith, varies throughout the year depending on the viewer's location. For example, on the summer solstice, a person located at 23.5 degrees north latitude sees the Sun's zenith directly overhead. At the equinox, it appears lower, and at the winter solstice, it is at its lowest position, shown in figure 27:17. Then it starts moving higher again to complete the cycle.